right, 6-1, day 2. Three examples is all we have. We went through most of the stuff on Friday. I gotta find an example though. Okay. Let's see, right here. We've got a random sample of 156 fields of durum wheat. So we're going to sample 56 fields of wheat. And those 156 fields had a mean yield of
How many fields?
156 fields. Yep, good catch. I said it, but I didn't write it. They had a mean yield of 26.8 bushels per acre. Bushels per acre, and a standard deviation of 8. Bushels per acre. Okay, we want to find well, I'm going to switch it up. I'm going to go 85% confidence interval. Or the population mean. So based on that sample, what do I think the average is for all fields of durum wheat? Okay, so I want to do this one by hand, then we're going to repeat it with the, just review from Friday, and then we're going to repeat it with the program that cranks it out right away. So I chose 85% for a reason, just so you remember how to find that z-score for the 85%. Okay, so our first step was to find the mean and standard deviation. Well, a lot of the problems, they just give you the mean and standard deviation. If they didn't, what would you do? If you had all the data. If we had 156 answers here. The one bar stat, it's got the mean and the F. But they tell us the mean is 26.8. The standard deviation is 8. Otherwise, it's one bar stat. Okay, what was the second step, if you remember it? You got it memorized yet? Our goal is to find big E. We're going to use INFORM here, but the big E formula is, remember the big E formula, max error? Z-score for your confidence level times S over square root of N. Okay, I've got the S, I've got the N, and 156. Do I know the Z-score for my confidence level? I chose 85% for a reason, to help Ashley out. 85% is in the middle, because we're doing a confidence interval that's in the middle. I need the positive z-score here, but I usually just find the negative z-score here and then just take the opposite of it. What do I need to know to find this z-score? What's in the left tail? So if there's 85% in the middle, that leaves 15% for these two divided evenly. What's the decimal? 0.075. So if you do the INF norm of 0.075, yes, actually this will give you a negative z-score. And what is that negative z-score? Out two places. 4.4. So what z-score are we going to use? Positive 1.44. So we're ready for 1.44 times by the S was 8.0, over the square root of the sample size, which was 156. So big E I got 0.92. Anybody else?
Yeah.
Okay? And then our third step is to actually write the interval. What do I expect the mean bushels per acre to be for all durum wheat fields? And how do I get that? Yep, the average was 26.8, plus or minus the 0.92. Now we actually do that. So I expect the average to be between 25.88 and 27.72. Yep. Okay, that is not a difficult process to go through, but your life gets easier with programs. So we're going to repeat this problem with a program, and I'll tell you how the program runs. So, confidence interval for population mean where we have large samples. Tomorrow we're going to be doing population mean with small samples. Okay, the first thing you need to know though, you need to know the mean and the standard deviation. So if they don't give you that, you still have to run the one-bar stats just like you did before. So the first step by hand and by program is identical. You have to find the mean and standard deviation. If you need to use the one-bar stats because it's all the raw data, you do that. If they give you the mean and S, you're ready to jump into the program. So, one-bar stats if necessary. Okay, the program is called Z-interval. We're doing confidence intervals, so these are going to be all the intervals. So we're going to be looking for Z-interval, and that can be found under stat over to test, and then you're going to go down and look for Z-interval. And we're going to be using the stats and not the data. Okay, so let's run through it now, see how it works, after you get that written down. That's the same problem as this. So we should match our answer that was followed by hand. Okay, is everybody ready? This up here for those at home. Okay. Guess you can see it pretty good about there. Okay, ready, stat? All the way over to test. Okay, notice you've got Z test, T test, 2 samples. We're going to be using all of these. We want intervals. We are doing confidence intervals. This next chapter we'll be using these top 6 programs. So that's chapter 7. Chapter 6 is all down here on the interval 7, T interval, 2 samp Z in. These are all of, this is the chapter we're on right now. We'll be using all of these over the course of this week. All of them. They go quickly. Z interval. Okay, we want the stat.
What number was that?
I don't know. Okay, Z interval. What is this? That's standard deviation. Do we know the sigma? No, but what do we use in place of it? The S number. That's a standard deviation. The only standard deviation we know is the S, and it's okay to substitute. That was 8.0. The mean. What was the mean? 26.8 bushels per acre, so 26.8. N, 156. Confidence level, 0.85. So you put it in as a decimal. calculate. About 1/10 of a second later, it found big E, did the adding and subtracting. How well does it match our confidence interval? Pretty darn close. So theirs go out 3 places, we went out 2. So you can run the program. So what's going to be the challenge at the end of this chapter? Which program am I supposed to be using? And it's all in the interval you're finding. We're finding an interval for the population mean with a large sample. Tomorrow will be population mean with a small sample. And now we'll do them, like Friday we did by hand, today we're doing program, now it's just going to be everything in one day. Chop, chop, chop. Huh? 30 is the magic number. But that's tomorrow. Okay, the last thing in here, we're already done. Yeah, that was pretty much. No, I guess not. We don't have to write that down. Okay, now, let's say, okay, it's called minimum sample size. To find a minimum sample size needed to estimate population mean for a given amount of error. So let's say you want your interval to be no more than, say, 5 away from the actual mean. So you're setting the amount of error you are going to allow. How big of a sample do you need to have that happen? Well, it's just taking that big E formula and working backwards. And we could do it, but I'll just tell you, well, maybe I'll do it. We'll go through the algebra. Okay, we're trying to solve this for n. What's my algebra step to solve this for n? It's my first algebra step. I don't see an add in there where I should be subtracting anything. The n's trapped in the bottom here. First thing I would do is get n out of the bottom. How do I get n out of the bottom? Multiply. So think of that. So the first thing we're going to do is multiply by square root of n on both sides. So we're going to multiply by square root of n. Multiply by square root of n. That cancels. So square root of n times e equals z-score for your confidence level times f. Solving for n, how do I get rid of the e that's with it? Divide both sides by e. Square root of n equals this fraction, z-score, times f over big E. And how do I get n? Square both sides. That's your minimum sample size formula for a given amount of error. So, how does this work? Try at number 6 is right here. Let's see. How many magazine advertisements must be included in the sample if you want to be 95% confident that the sample mean is within 2 sentences of the population mean? Okay, this goes back to that one we did on Friday. So,